Hey guys, so in this final video about microservices, we are finally going to tie this all together and make all of our microservices talk to each other in order to produce a web application. So let's get into it. The first thing we want to do is that we want to go to our web interface, and as we can see here, we are now working with our web application that is running on port 3000. As we saw in the earlier video, this is the web interface serving part of our application. Now, the issue here is that we have all these different services, right? And they are all running on different ports, as we saw in the last video. We have port 3000, 3001, 3002, 3000, like all these different ports, right? And this client, like when the user comes to our web page, we can't actually, we shouldn't, and in some cases we can't actually specify both the domain name and the port we want things to be mapped to. Now, in theory, we could provide different domains for each of the ports and map that and do all of that hassle, but that's a lot of work. And the thing is that there's a much easier solution to kind of deal with this, and that is to provide a entry point or a gateway for the basically the clients who want to access our system and have that client, or rather that gateway, know where everything is. And that's where Nginx comes into play. So let's start by let's try using this localhost 3000 in Microservice, the web interface that we're using. Let's just click search now and see what happens. Okay, so we get an error message, and this is one of the main reasons why if you're doing this and you're trying to do network calls to the different containers, that this will actually not work, because you have the access control allow origin header, basically or rather the cross domain request policy, the course policy, which states that you are not allowed, especially from JavaScript, you're not actually allowed to make a request to a different domain. And we'll look at the client code in just a moment. So from our client code, we're trying to access localhost 3000, that port number, or sorry, 8080, and access the search function on that page. But since we're serving this from localhost 3000, we won't actually be able to do that. We can't actually do the AJAX call. Now you may say that, oh well, Frederick, that's easy. Why don't you just change the network request to something like, why don't you just serve this page from, or rather, why don't you just change like the port number or something like that so that it's all running on the same domain? Yeah, it is true that I could put search in the same application as localhost and put them on the have all of it run in the same application, but then it wouldn't be microservices now, would it? It would just be a monolithic application. And this is kind of where I've been saying that this is where some of the complexity comes into play, because you microservices are powerful, but they introduce a lot of more complexity to your application, because you're absolutely right. I mean, there's no reason why my search function couldn't, like the search endpoint couldn't have been with my web server. I've sliced it up into these tiny pieces, and I urge you once again, don't do this unless you have really large systems. But this is, as I've said, this is for learning. So now that we know that we can't actually just we can't in hard code the different services and their port numbers in our client code, we have to take it one step further. So let's look at this page instead. So on localhost 8080, we are running Nginx basically, and Nginx is a reverse proxy and HTTP server, which basically means that it's a server that can serve up static content, and it can also proxy requests to different endpoints. Now, if I click search here, notice that there was no error, and the search request actually went through properly, and I got no results back because we haven't actually added anything in. So let's put some stuff in here. This is awfully small. Let's size this up a little bit, and let's put that to 100%. And then I hit submit, I click these buttons here, and as you can see here, this is all our entire application. We can see the calls going out here. So what we're seeing here is that, all right, so I hit search, it went to 8080 API version 1 search. I went to books, and it did the same thing. I went to videos, and it did the same thing, but they are all running on port 8080. So what's going on there? Because we know from the previous videos that, hey, I mean, these things aren't really, this is not correct. These things are mapped to different ports. And that's what Nginx allows us to do. That's what's so beautiful about it. It acts as the entry point, and it decides where the network request is going to go. So you can have a single place where all of the network traffic is coming in, and then it dispatches to the correct service that we're using. Now, let's look at how that actually works, because this is absolutely magical. Let's look at our configuration. So here we are. So this is a very, very basic setup for Nginx, and I'll show you how this works with like Docker, because in the next section of this we're going to talk about Docker Compose and how we make all of this connect together, and it will make sense in just a moment. But let's just walk through it. So the first thing we do is we declare a server, and then we say that, hey, we want this server to listen on port 8080, and then we set the root of our static files to server www static basically. And then we have these location blocks, and this is where the magic happens. So this, once again, this is a very there you could make an entire video series, and I'm pretty sure people have on just Nginx because it's such a powerful and massive tool. So I'm just going to step you through the bare bone basics. Location is a way where you basically declare a route that you want to do something with. It's just a piece of logic where you know, okay, so somebody made, let's take this one, somebody made a location request to Nginx for just slash for the root or something of that nature. All right, cool. So when somebody does a slash request, we want to do some stuff. So here I put a comment. We try to get static files from Nginx first, because Node is not great at I/O operations. So what does that mean? Well, then we have this macro here, this convenience method basically, which is called try files. But basically what it does is it allows me to declare a sequence of places where I want to look for a given static for a file basically. So I check first and foremost, this is going to be in the root of this directory here. So server www static so forth. Basically what this means is that if I just try to find the file, quote unquote, that I'm looking for in my browser, so when the browser is making a request for say a CSS file or for an HTML file or anything like that, if it matches this URL pattern here, go and look for it in the place that I'm specifying in the context of this root here. And then I do one for, with a slash and without a slash and with a slash. And then finally I have this weird thing here, which is @web. This is a named location. So basically what I have specified is that this is a location now, but it's not mapped to a URL like these others are. It's just a name, so I can reference this location from other places in my configuration. And so what I'm saying here is that, if you're hitting this variable, send the request or use whatever's in this location block basically. And in this location block I have a proxy pass, which basically means that take the incoming request and send it to this location here. So what's happening here is that we are first checking in our Nginx instance if we can find the file. If we can't find the file, when we're just at the root level here, we're simply going to send it to our web microservice. Why are we doing this? Well, because if we look at our index.html file here, notice that it's just a static file with some JavaScript. It has no rendering. It's not rendered at all. So why, and then that brings the question, why in the world would we want Node to serve that stuff up? Because we know that Node is really shitty at I/O operations. Like, Node is amazing in many, many ways, but when it comes to HTML and like serving static files and all of that stuff, it's not that great at doing it. So it's much healthier for our application if Nginx takes care of it. So if we just look at localhost 3000 here, we look at the network request here, and we get the index file. Notice that we have this custom header that I've been too lazy to remove, which is called X powered by Express. So on port 3000, we're actually hitting the the web microservice. But if we go to Nginx and we do the same thing, notice that that header is no longer there, and we're actually getting this file from Nginx, and that's much better because now we saved some time and we saved some load on our microservice. But let's say that we had a rendered file. Let's say I did foo.html. Now because I don't have anything that maps to foo.html or something like that, we're actually now hitting the web server, like the server that that is running on port 3000. So that's a beautiful way where you can kind of mix static files like a 404 page or something that doesn't need any rendering with, so that you can serve, like basically you can serve the static files from Nginx, and you can render the stuff that you need rendering, that stuff that actually needs to go to the server in the server. I think that's really powerful and I absolutely love it. So let's look at these other mappings. So you have API version 1 search, and then we have depends on, and then we have books and videos. And as you have seen in the previous videos, these locations perfectly map to endpoints on our different servers, or the different microservices that we have running on our system. And basically, all of that's happening is that Nginx is taking the request, looking in this file and seeing, oh yeah, this URL here, it matches perfectly to this thing here. I'll just send that request over to that microservice. So this is the gateway where everything is coming in and then being sent to the different locations in our distributed system. Now, I will be honest, this is, if you have a really large system, it can get really tricky to maintain this. I argue that this is probably one of the most simplest ways I've ever used Nginx, and it's the way that of course, there's a lot more that we do at my company, but we do something very similar to this, and it's very easy to get started with, and I actually really like it. But there are a more efficient way to find all of these endpoints. Anywho, you may now notice as well that we're using this stuff that we saw earlier. Instead of saying localhost or an IP address, we're just setting a domain, basically a domain name that maps to our different module names, and that's going to work. And we're going to talk about that in just a moment when we start looking at our compose file, because that's a fairly important thing. So let's just end on tie up this whole front end thing and like basically how our web application is actually working on the client code, so that we can focus on the last section, which is just going to be about the containers and how they talk to each other. So here we have this simple page that we saw earlier. We have the create books, create videos, and search interfaces, and what we basically have done is that we have said that instead of just doing a network request with a render, with like a re-render and all that stuff, we're going to use Ajax. So on submit, we are going to return api.savebook, api.savevideo, and api.search. So you see, this is it's just a demo application. And since we're not using Webpack or anything fancy like that, we're going to go old school and use a self-instantiated module or a scoped instantiation or a self-invoking function. There's a million names for this stuff, basically. But basically what it is that all this code you're seeing in here, it's wrapped in a closure that immediately as the browser hits this script tag is going to be invoked, and it's going to return this object with all of these functions to the API variable. And this is very nice if you want to do vanilla JavaScript, because that way you can actually namespace your different functions that are on the page without having to make sure that you're not colliding with different function names and all that nastiness that you have to deal with. So here we have some functions basically, This one is fairly simple. All it does, it's a higher order function that takes in a selector and a function that is going to do a network request with whatever it's being passed. So basically what we do is that we get a query selector for the selector, we get the value, and then we just run that function with that value. And if there's an error, we log it out and then we return false, which is going to help us with this onSubmit, because onSubmit needs to have false return in order for it to not actually do a method, like do a form submission which will re-render the page or refresh the page basically. So then we have a make post name func, which is going to take in a URI and return a function that is expecting a value. So it's going to internally do fetch with the URI we give it. It's going to be a post, and then it's going to do a JSON stringify with names, like basically the value is going to be set to name. And then we have our headers here where we say that we can accept application JSON, and then we're content type this application JSON. And what that allows us to do is to generate these two functions here, where basically all we have to do is that we have to give it the endpoints that we want these calls to be made to, and then these higher order functions just create the function that we want. And as you can notice now, both of these are mapped to the same host. So this is going to be the same address, and this is what's happened. This is what we saw earlier. So what we're doing now is that we're going to Nginx API-v1 videos, which is going to be in this file, and it's going to map to this and that and send it to the correct microservice. Cool. And the same thing is happening down here for search. We're just doing a fetch to the search API, and we get the response, we get it convert it to JSON, and then finally we grab the UL element we saw earlier, we clear it, and then we loop over all of the responses we got, create list items, and then we set the list content here with string interpolation to 2p, like just 2 paragraph tags basically. We set the inner HTML, and finally we append all of that stuff. So that's basically what's going on here. So whenever I'm doing a submission like that, all of that is being executed. It's not the most beautiful code in the world, I will admit. Webpack does this 100 times better, but I wanted to keep things vanilla and pretty simple. Hopefully this is good enough now. So let's move on. Let's talk about Docker Compose and orchestration, because the thing is that now that we have a few services, we don't want to just use Docker to do like all this manual work, because otherwise we would have to, every time we made an update, we would have to like go into Docker build, and we would have to run all these separate commands just to get everything to work as a swarm of services talking to each other. So now we know that we have these services, they can talk to each other, and we know that thanks to Nginx, we can actually let a user or a client or something like that get to where they need to be going, and we can direct them, and we can serve static files. So finally, let's talk about Docker Compose, and then we'll end on that note. So Docker Compose, what is Docker Compose? Docker Compose is an orchestration tool that allows you to manage multiple services or multiple containers and declare how you want them to work together. So all it is a YAML file where you declare how everything is going to be tied together. So I'm on version 3 right now. There are a few versions, so let's just walk through it. So here I declare my services, and as you can probably recognize here, we have a web service. And when we build the web service, we declare that it's going to be in the web directory. Then we say that, hey, I want to connect the port on my host machine, port 3000, to the containers port 3000. And then we have search, which does the same thing. But there's a difference here. We see that we have this clause here called depends on, and that's basically where I can declare now that the search, well, in order for that to work, I need the database, and I've named my database. If we go down here just a smidge, we see here that I've named my MongoDB instance to database basically. We'll talk about that in just a moment, but that's the same name, so that I can declare now that, to Docker Compose, start the database and then you start the search, okay? And here we have something that we recognized from our earlier video. Remember when I was showing you that in my configuration like this, I check if there's an environmental variable that knows where my database is located. And if there is one, I'll use that instead. That's what's happening here. This is what I'm doing. So I'm saying that, all right, I am going to now not use my host machines like localhost. I'm not going to use that at all. I'm going to use the container, because what Docker Compose will do is it will create an internal network for all of these containers so that they can connect to each other. And I want to use that instead. So I declare my variable and I set that to MongoDB ://db, and we'll talk about this in just a moment. I know I'm building up to it, /microservices, which is basically the same thing we saw earlier, but with this hostname being the difference. So let's just actually touch on that now. I've been delaying it for long enough. So the way that MongoDB works in version 3, or rather what it will do, is that it will declare, like when Docker Compose connects to creates a network, and you set all of these services up on that network. What Docker will do, it will modify the host files of these services so that that the IP address that you can where you can find all of these different microservices, or these containers rather. It's not necessarily microservices, but these containers, they will be given a host name, and that will be added to the host file of the container. So this is actually extremely powerful, because if you hard code the IP address, you're not guaranteed that IP address will always be the same. But thanks to the genius people at Docker, now you can simply use this instead. You can just use the name that you gave. So for me, it's the database that I want to find. This name, you just put that as the host, and that will resolve in the container to the IP address that where you can find that container. It's extremely powerful. I really like it. Let's move on. So we have some video. We have our videos module. We go and we build from the videos directory, and then we have our port mapping, and we saw depends on and environment. So now finally we will look at the base containers, or the root containers that we use. So we declare a database, and you see here that we're not building Mongo. Why are we not building Mongo? Well, we're not building Mongo because we don't have to. We don't have to add anything to this finished image. All we want to do is to say that, hey, can you go to Docker's container repository and just grab me MongoDB? And just give me a container with MongoDB, basically. And there are so many containers. You can get tons of them. It's really awesome. I urge you to check it out. And then we have our port mapping, and then we have Nginx, where a little bit of magic is happening. So let's look at that. So here we declare that we want Nginx, the latest. We should have probably done that as well up here. Let's be sloppy. I don't care right now. Let's just keep it like that. So in Nginx, the declaration, we get the image, and then we map the ports as we saw, and here's a difference. Volumes. What's going on there? Well, volumes is a way for you to connect your host machine's file system to the file system of the container. So what I'm saying here is that, hey, can you go and connect the web module, this folder here, can you connect that to the container's server www static directory? And as we saw earlier, that's where Nginx is getting its static file from. So what I've done is that I have just connected on my local file system basically this directory. In production you would probably copy it over and stuff like that. I'm just trying to show off some features here, but you can copy it over, or you can build it and stuff like that. It's a little bit of a different process, but this is very useful, especially for local development, where you can just connect some part of your own file system to the container's file system, and it will actually allow you to make, let's say, this is what we're going to talk about next. Like, I can actually modify the files on my local file system, and since they're connected to the container, it will propagate to the container. So this default conf file here, which we have here, so what I'm doing here is that I'm connecting this file. Basically, I'm taking this file and I'm adding it to the file system under this root here inside of the container, which is where Nginx is running. It's where it's reading its configuration. So I can actually modify this whenever I want, and just, I can either restart the restart Nginx, or just restart the container, and it will propagate immediately. I don't have to rebuild or anything like that, or copy any files. It's just very nicely connected. And then finally we have our dependency. So this Nginx should be the last thing to start, basically. So it's depending on all of my services, because, and just to make sure that everything is up and running before it starts. Okay, so yeah, let's summarize all of this. So what we've learned now is how the basic idea of microservices work, and how you can, using Nginx and Docker Compose, kind of just orchestrate all of these things together. And yeah, like I can only say that it is, as you can see, it's very, very easy to spin up an entire fleet of services and have them talk to each other. I can do all manner of cool things with Docker, and I feel that it's a very, very powerful tool. So yeah, basically I'm going to leave you here, and I'm going to say that, once again, microservices are really great for really large projects. I wouldn't warn you to use them on at small scale. And I think that if you want to use Docker and Docker Compose and Kubernetes and all of these powerful, and Nginx and so forth, these are powerful tools. I use them every day at work, but we don't use microservices necessarily, because you can use all of those tools without having to do microservices. If you really want to work with microservices or something like that, look for a company that, start working at the company that has the type of size where you can actually get to play around with this technology. But don't take your own, like, if it's just a toy project, if you're just doing something for yourself, then absolutely do what I did here, just go crazy and have some fun with it. But don't, like, build your own little company or something around it. I've been there, and it's there is a lot of hassle and a lot of problems that comes with it. Hopefully this has been useful to you. I'll see you around.